2D shapes are flat, like a piece of paper, here. They would not be in a 3D movie. They would be flat.
That was upside down, Miss Walsh. Thank you.
We don't want to reference the 3D shapes that might confuse them. Just the plain piece of paper. All right, so we're trying to find, area is trying to find the amount of units that fit inside a 2D shape. So if I had a rectangle with the side of 3 and another side of 4, one way that you can do this is break apart how many units long the rectangle is. So it's 3 this way, so I'm going to break it into 3 this way. And it's 4 with the width, so I'm going to break it apart into 4 here. So I have 1, 2, 3, 4, and then 1, 2, 3. I've broken it up into equal units, so now I can count the inside and that would tell me the area. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area would equal 12 units. And we would say cube. That's what the 2 means, because what did I count up? I counted up, no, squared. Squared. I'm getting ahead to volume. Ignore me. Okay, these are units squared, because what shape is this? It's very similar to a square. That's what this means. Mr. Unkin, you should have corrected me.
I was thinking about it, but I figured you'd get it.
Okay.
It's all right.
All right, there's another way to do it without counting up the unit squares, because we'll be getting into problems where we'll be asked to find the area of a rectangle that has a length of 72 and a width of 108. And me going through and writing out 72 this way and 108 this way, I could do it, but it would take a lot of time. So if you remember, there's an area formula for this. And we know that 3 and 4, what do we do, what sign do we put here to get an answer of 12? Do we do 3 plus 4, 3 minus 4?
No.
3 divided by 4? What would we do, Mr.
It's
Hawkins?
3 groups of 4, so I think you'd multiply.
You're right, we would multiply. So the formula is length. Which one is length? Does it really matter? Base times height? Base, I'm going to do base because we talked about that before.
That makes sense.
Base is the bottom, and height is like how tall we are. So base times height. That's what the B means. The B means the base, and the H means the height. So if I replace, for the letter here, 108, which is my base, times 72, which is my height. Now, we are going to let you use your calculators for this assignment. So I'm going to walk over and grab a calculator. And I'm going to type into my calculator 108 times 72. And I will get my answer, which is 7,776. So this is equal to 7,776. And since I didn't say this was feet or inches, I have to write units. And just like up here, I could have counted all the squares inside this, but I didn't because I used the formula. I have to show the square side. All right, I'm going to do another one with you because we're going to review triangles as well. All right, so let's start with a right triangle. If you remember, right triangles have what angle in the corner of them, Mr. Onken?
It is a right angle.
And can you remind us how many degrees a right angle is?
90.
90, good job. All right,
I have a math joke, Miss Walsh.
do tell us.
Where do you go if you're cold?
I have no idea.
To the corner, because it's always 90 degrees.
Oh my goodness. All right. Anyways, moving on. Thank you, Mr. Onken. I know the kids really missed those jokes. If my height is 3 and my base is 4, what shape is, how do I want to say this?
What if you drew dotted lines to make it?
I do want to do that, but I want to explain to the 5th graders why the formula works. So I guess I'll just show them this. What are these two shapes independently, Mr. Onken?
Triangles.
Triangles, and two triangles together make one shape altogether.
A rectangle.
A rectangle, right? So if I do the same thing as before and I count out my units, I do 3 across and 4 this way, I'll get what?
It would be 12.
12, right? But that would be for all of these,
Mm-hmm.
right? And we said that the two triangles, are they equal triangles?
Yeah.
Yeah, so could I take my total area of 12 and break it into 2?
Yes.
Yeah. So if I have 2 groups, so like let's say this is 12 donuts.
Yeah.
We want to share between Mr. Tauchi and Mr. Hayden. If I give one to Mr. Tauchi and one to Hayden, 1, 2, 3, well, I'm way off. 5, 6, 7, 8, 9, 10, 11, 12. How many donuts do they each get?
They each get 6.
6, right? So half of 12 is 6. So the area of just this triangle would be 6. So the area is equal to 6 units cubed. Now there is a formula for this one as well. And I'm going to erase some of my work and maybe move this over. Okay. So the formula, let's think back to what we did. We multiplied our base by counting them out. We multiplied our base times our height. And then when we split up the 12 between Tauchi and Hayden, what did we do?
We divided it.
Divided it. So the area formula for a triangle is base times height divided into 2. Because 2 triangles will always fit into 1 rectangle or 1 quadrilateral, which means 4-sided shape. I got nervous that I was going to say something different in my head. All right. So if we have the problem of 18 is our height and 29 is our base, and I'm going to say feet this time because I've been really bad about labeling. Just like before, what nifty tool can we use on this assignment, Mr. Onken?
Calculator.
Calculator. So first thing I'm going to do is I'm going to take my base, which is 29, times my height, which is 18. Oh, and I hit add, but it still worked. Okay, so I got 522. Mr. Onken, am I done?
No.
What do I need to do?
You need to divide it by 2.
Divide it by 2. And that's a common mistake we see with 5th graders is they get really excited because they're like, oh, I know. And they always forget the last step. So remember to divide by 2 because this isn't a square, rectangle, or quadrilateral. It's a triangle. So the answer is 261.
And make sure when you do your multiplying that you do your multiplication, see that big number before you divide it by 2. You've got to hit enter first
Yes.
on your multiplication.
Thank you, Mr. Onken.
Mm-hmm.
So that's how we do that. All right, one thing I want to review with you because it will be on your homework is finding the perimeter. And I like to think of perimeter as if I was putting a fence around like a yard or something of any shape. And fences, do they ever go inside the shape, Mr. Onken?
No.
No, you have a yard, you don't want fences crossing all through it, whatever. You want it right on the edge. And we want to find out how long the fence would be, because if we were fence makers or fence buyers, we wouldn't want to pay for extra stuff, right?
Nope.
Okay. So if I am fencing in my yard, this is my yard, and I know that the base of the yard is 109 feet. Got a nice size yard, kind of. And then a height of 56 feet. How would I figure out the total distance around? Well, this is a shape, and we know it is a shape. It's a rectangle. And if this side is 56, this side must be 56. Because rectangles have opposite sides that are equal. And this side, if this is 109, this must be 109 as well. And then we add them all up. So 56 plus 56, which accounts for this side and this side. And then 109 plus 109, which accounts for this side and this side. The reason I broke these two up is because it's easier for me to add them up. You don't have to do that if you don't want to. 9 plus 9 is 18. 0 plus 1 plus 1 is 1. 218. 6 plus 6 is 12. All right, now I'm going to add these two up. So the perimeter of my yard would be 330 feet. Same thing if I had a triangle and my sides were 19, 24, and 16. I would add all three sides because I'm trying to find the total distance around. All right, that's all you need to know.
Thank you.
Yep.